Okay. All right, everybody. Polynomials. Yeah. What does poly mean? No. Huh? Many. More than one. What did nomial mean? Huh? Yeah, term. So a polynomial is an expression with multiple terms. Okay? We talked about 3 types of polynomials yesterday. What is one type? Binomial. What's an example of a binomial? 3x plus 4y. That's perfect. 2 terms. What was one of the other types of polynomials we learned about? Huh? Trinomial. Somebody give me an example of a trinomial.
3b plus 7y.
But then I could just add the 6y and the 7y and make it 13.
Oh, wait, I meant x, not y.
There you go. That's good. Perfect. 3 terms. 1, 2, 3. And what was the third one? Huh? Monomial.
3x.
Perfect. 3x, right? Monomial has 1 term. Binomial has 2 terms. Trinomial has 3 terms. Polynomial is the umbrella under which all of those fall. Okay? I'm going to teach you a couple more little vocab terms just so you know what I'm talking about when I'm teaching. First, and a lot of these things you will look at a whole lot more when you take Algebra 2. We don't talk about it too much in here, but so I just want to tell you about the vocab. Dylan, can you sit up here, please? Degree, constant term, leading term,
Are we supposed to be writing this down?
yep, leading coefficient. Okay. 4 new little terms, and rather than like writing out the description or the definition of these things, let's just look at an example, okay? So, okay, this is a polynomial. Is it a monomial? Is this a monomial? No. Is it a binomial? Is it a trinomial? No. No, it's just a polynomial. There's 4 terms. So the degree of a polynomial is the highest exponent in that polynomial. What is the highest exponent you see in here? The highest exponent. 3. That's the degree. So this is a 3rd degree polynomial. A polynomial with a degree of 3. You say that. Okay? The constant term. Any idea what the constant term would be? Huh? So what term doesn't change? No, the variable varies. The variable changes. So we have 3 terms with a variable and 1 term without the variable. Which term doesn't have a variable? The 8. That's our constant term. When we talk about a constant in math, it's just talking about a regular old number, plain number, no variable attached to it. So 8. Let me use like different colors. Do that. 8. Right? Okay, what about the leading term? What do you think that would be? Huh? So that's what you would think, isn't it? But it's actually, it's the term that has the highest exponent. That's it, 4x cubed. This whole term would be the leading term. It's the term. No, I don't know what happened to that little circle there, but no, it's not a -3. So that's 4x cubed. And then, so what do you think the leading coefficient would be? Not the first number. What's the leading term? Was this, right? So what's the coefficient of 4x cubed? The coefficient?
6x -6.
So the coefficient is just the number out in front. So the coefficients are 3, 4, -6. Not really 8 because it doesn't have a variable. Okay, it's the numbers before the variable. The leading coefficient would be then 4. It's just the coefficient of the leading term. Does that make sense? Okay. You do a lot with this stuff in Algebra 2. Yeah, it's kind of fun. Actually, I like it. Okay. Okay, 3 other little terms really quick. Linear, quadratic, cubic. Linear, so we've looked at a lot of linear relationships, but something like this. 2x plus 7. What is the degree of this? 1. Perfect. Degree 1. A quadratic looks like this. What's the degree of this? 2. Just looking at the highest exponent. A cubic is like this. What's the degree of that? 3. Okay. That's the new stuff. We talked a little bit about this stuff yesterday, but then what else did we do yesterday? What did we learn how to do with polynomials? Addition, yes. And what do you think we're going to learn today? Subtraction. No, we'll do multiplication next week, which is my favorite thing to teach. Addition and subtraction. So when we are adding polynomials together, it's going to look something like this. Something like this. What did we say yesterday was the first step when we're adding polynomials? Huh? Remove the parentheses. So it's 3x minus 2 plus 4x plus 5. Simple enough. What's my next step gonna be? Yeah, we gotta look for our like terms. So just start from the left and work our way right. What's a like term with 3x? The 4x. And then what's my like term with the -2? The 5. Good. So I can rewrite this now, and I can do this, 3x plus 4x minus 2 plus 5. Some of us might be able to do this part in our head and kind of skip these steps or kind of combine these steps all into one. That's okay. But I like to show it so everybody can see all the steps we go through. Okay, so what's 3x plus 4x? 7x. And -2 plus 5? 3 plus 3. And that's your final answer. Cool? It's pretty easy, isn't it? Yeah. Okay, now let me show you subtraction. It's really similar, but just slightly different. Eduardo, put it away. So I'm going to use the same. What are these called? What's 3x minus 2? What kind of polynomial is that? Binomial. So this is a binomial plus a binomial. Let's do a binomial minus a binomial. So we'll do 3x minus 2 minus 4x plus 5. So there's one big difference when we're subtracting, and that is we have to distribute the negative sign to the second polynomial. So the first polynomial stays exactly the same. You can just copy it down. 3x minus 2. But then we distribute this minus sign. So we do minus 4x minus 5. Yeah, but if they're negative in here, you're going to make it positive, which I'll show you that in a second. Okay, so now it's the same exact steps. I still look for my like terms, right? I have my 3x and my -4x, and I've got this -2 and a -5. 3x minus 4x gives me what? Huh? Yeah, -1x, good. Or just -x is fine. And -2 minus 5? Okay, cool. Let me show you this. So if these, let me just show you a different one. So we've got 2x plus 8 minus 4x minus 6. What's my first step when I'm subtracting? Hey, and I've got practice problems over there now, Isaac. So you gotta do a practice problem before you leave. Distribute the negative sign to all the terms in that second polynomial. So first one stays the same, 2x plus 8. And then we do minus 4x. And then this part becomes minus -6. Exactly. So essentially when we're subtracting like this, you switch all the signs of the second polynomial, right? What's positive becomes negative, and what's negative becomes positive. Does that make sense? Yeah? So now I've got this, 2x plus 8 minus 4x plus 6. Same steps. I look for my like terms, 2x, -4x, so 2x minus 4x, and I have a positive 8 and a positive 6, so plus 8 plus 6. And then I combine the like terms. So 2x minus 4x. Go ahead, negative 2x and 8 plus 6, 14.